Hello students, after a long time I'm sending you an explanation. We are going to start with the first chapter of organic chemistry, that is haloalkane and haloarenes. So what we understand by the term haloalkane or haloarene? You know that alkanes are having one carbon is attached to all hydrogens. These are called alkanes. Now if I replace one or more hydrogens by an halogen, then the class of compound which we get is called haloalkane. And same is with arenes also. We know in benzene ring we have all the corners occupied by hydrogen. Now if you replace one or more hydrogens by a halogen, then the class of compound which we get is called haloarenes. So that's what we understand by the term haloalkane or haloarene. Now let us move to the classification. So this classification will be common for all the chapters. So I am giving you only here. Next chapter onwards you will do it on your own. Basically, the haloalkanes can be classified into two categories. When the carbon to which halogen is attached is sp3 hybridized, as you can see here, or the carbon to which halogen is attached is sp2 hybridized. So we shall concentrate mostly on this. Under this we have three categories: normal haloalkanes, allylic haloalkanes, and benzylic haloalkanes. Now what we understand by the term normal haloalkanes? You see, normal haloalkanes is when the alkane is substituted by a halogen. They are of three categories: primary, secondary, and tertiary. Primary means the carbon to which the halogen is attached to only one more carbon, and secondary means the carbon to which halogen is attached to two more carbons, and tertiary, as you understand, the carbon to which halogen is attached to three more carbons, as it is very clear here. So, and what we understand by allylic? By allylic we mean the carbon to which halogen is attached to another carbon which is attached to a double bond. You see, the carbon to which halogen is attached to a carbon-carbon double bond. Such a system is called allylic system. And then what we understand by benzylic system? By benzylic system we mean the carbon to which halogen is attached is attached to a benzene ring. Such a system is called benzylic. So be very clear with the classification part. Then we move to carbon, sp2 hybridized carbon and halogen. Under this we have two categories: vinylic and aerylic. Vinylic and allylic, you should not have any confusion. In allylic, the carbon to which halogen is attached is sp3 hybridized, and here the carbon to which halogen is attached is sp2 hybridized. That means the carbon which is bearing the halogen itself is bearing the double bond also. Whereas in allylic system, the carbon to which halogen is attached to another carbon which is attached to a carbon-carbon double bond. And aerylic means the halogen is directly attached to the benzene ring, unlike benzylic. As you can see, the difference between benzylic and aerylic. In benzylic, what happened? The carbon to which halogen is attached, this carbon is attached to a benzene ring. But here halogen is directly attached to a benzene ring. So that's how we classify the haloalkanes. Now what is the general formula of haloalkanes? As we said, we can substitute one or more hydrogens in the alkane by a halogen to get a haloalkane. So to make our study simple, we'll restrict ourselves to monohaloalkanes. Now what do we mean by monohalo? As the term mono means one, monohalo means one halogen. So when we are substituting an alkane by only one halogen, the class of compound which we are getting is called monohaloalkane. And the general formula is CN H twice N plus 1X, where N is greater than or equal to 1. So, in common name system, haloalkanes are called alkyl halides, and the commonly used halogens are fluorine and bromine. Usually fluorine is not studied much. Iodine also is not so much. Of course, it is studied. Now we take the first example where n is equal to 1 and have chosen the halogen to be Cl. We replace the value of n here by 1 and replace the halogen by Cl. So what we get here is CH3Cl. So the IUPAC naming system is alkane minus haloalkane. So halogen has to be named first, followed by the alkane. So name of this is chloro, which is the halo part, and alkane is, since we have only one carbon, so it is methane, chloromethane. And by common name system, it will be methyl chloride. Remember, in chloromethane, we are not supposed to leave any space, whereas in methyl chloride, you may leave a space between methyl and chloride. So this way, when n is equal to 2, we replace the value of n again in the same formula, CnH twice n plus 1 x, and again I have taken x to be Cl, and the molecular formula we get is C2H5Cl, or if I convert it to condensed form, we get CH3CH2Cl. So as the name you can understand, name will be chloro. Since there are two carbons, so it is eth, and because of alkane it is ane. So chloroethane, but common name will be ethyl chloride. N equal to 3 onwards, we start getting the isomers. So you can see here, when n equal to 3 and have chosen the halogen to be bromine, so the first structure which we get, molecular formula is C3H7Br, and there are two possible structures. In the first structure, the bromine is attached to carbon 1, and the second structure, bromine is attached to carbon 2. In both the cases, the carbon chain length is having 3 carbons. So the first one is 1-bromopropane, second one is 2-bromopropane. I just remind you, when do you put the hyphen? Between the name and the number, you put the hyphen. And when we try to name them by common name system, the first one, as you can see, it is a straight chain molecule, so it is termed as normal. So normal is represented by the symbol small n. So name of this is N-propyl bromide. And the second one, the bromine, the carbon bearing bromine is attached to two CH3s. Such a system is called iso. So name of the second compound is isopropyl bromide. So I hope the names are clear. Now let's move to the next molecule where n is equal to 4 and the halogen I have chosen to be I. By the way, before I proceed further, please remember in example 3, the kind of isomerism the two molecules are possessing is position isomers, because you may check they have same name but only the position of halogen is different, so they are position isomers. Next, number 4, C4H9I. How many isomers are possible here? As you can see, we have drawn here 4 structures. The first structure is having carbon with a 4 carbon chain, and iodine is attached to first carbon. So name of this is 1-iodo-butane, and common name is N-butyl iodide. Second one, I am keeping the carbon chain 4, but I am placing the iodine in second carbon. So name of this is 2-iodo-butane. So I think you can clearly understand number A and number B, they are position isomers. But look at the common name. The common name of the first one, as usual, is N-butyl iodide because it is a straight chain molecule. But in the second one, number B, you see, it is not iso as it was here. Here it is secondary butyl iodide. By secondary, in short, we write SEC. It is secondary because the carbon which is bearing the iodine is attached to 2 other carbons. But these 2 carbons are not CH3 groups. Here both the carbons were CH3 groups. That's why it was iso. But here both the groups are not CH3, and hence it is not iso. So it is secondary butyl iodide. And number 3, we reduce the carbon chain length to 3, and the fourth carbon we create a branch in the central carbon. So, and we place the iodine in the first carbon. So name of this will be 1-iodo-2-methyl propane. Here you need to be careful with the alphabetical order, which one should be named first. Okay, here 1-iodo, because I comes before M, 1-iodo 2-methyl propane, and here the common name is isobutyl iodide. Why is it isobutyl? Because you can see here, this is the carbon where we have two CH3s are attached to it. So when two CH3s are attached to one carbon, we call it iso. And why is it butyl? In common name system, normally we don't consider the word root by the longest chain. We consider the word root by the total number of carbons. So here altogether we have 4 carbon, and there are two CH3s attached to one carbon. So it is isobutyl, and the halogen is iodine here. So isobutyl iodide. If the halogen is bromine, then it will be isobutyl bromide. If the halogen is chlorine, then it will be isobutyl chloride, like that. And in the fourth structure, what did we do? We kept the carbon chain of 3. You can see the longest chain of carbon is 3, this way or this way, whichever way you go. The longest chain of carbon is 3, and both the branches are on the same carbon. Okay, I mean iodine and methyl both are attached to carbon 2. So it is 2-iodo 2-methyl propane. So I have written here follow alphabetical order. So please keep that in mind. And while numbering the carbon chain also, here for numbering the carbon chain also, you need to be careful which carbon you number 1. Okay, so here it is tertiary butyl iodide is the common name. And the kind of isomerism they possess, you may check. Number 1 and number 2, A and B, they are position isomers. 3 and 4 are also position isomers. But A and C and B and C, A and D, B and D are chain isomers. Because here the word root is but, here the word root is prop. Here also word root is but, here word root is prop. So they are possessing chain isomerism. Next we move to a special kind of class of compounds called allylic compounds. You need to be very careful in naming the allylic compounds. This is allylic because you can see here the carbon to which halogen is attached to a carbon-carbon double bond. Now how we numbered the carbon chain, that is very important. You see, I have tried to explain by numbering the carbon chain from both right to left and left to right. Once I have used a blue color ink, and here I have used a black colored ink. Let's try to understand them. Now if I consider the blue coloring, then you can see at carbon 1 we have iodine attached, and at carbon 2 we have a double bond attached, that means alkene. So my set of locants are 1 and 2. Whereas if I consider the black numbering, at carbon 1 we have the double bond, and at carbon 3 we have the iodine. Correct. Now here my set of locants are 1, 3. So definitely if we follow the lowest locant rule, we should go by 1, 2, not 1, 3. But here comes a special rule. You see, in both the cases, my first position of substituent is at carbon 1. Here also carbon 1, here also carbon 1. In that case, you have to check what is the priority. Which functional group has more priority? Here I have a halogen and here I have a double bond. Now if you check the class 11 book, the priority series, if you remember, we discussed in the class, alkene is having more priority compared to halogen. So though we have set of locants higher here 1, 3 and here 1, 2, still this is the correct way of numbering. So what will be the name of this particular compound? Name of this compound will be 3-iodo prop 1 in, not 1-iodo prop 2 in. Okay, I have mentioned here, please check. Very important rule. And that's how we name the allylic compounds. Then let's see how to name the benzylic compounds. In benzylic compounds, you see the halogen is attached to a carbon, which in turn attached to a benzene ring. In such a situation, what happens? This side chain always becomes the parent group. This side chain becomes the parent group. So in the parent group, I have only one carbon, so this will be meth. Alright. And what will be the name of the benzene ring then? The benzene ring is termed as phenyl. Whenever benzene ring is not the parent group, it is termed as phenyl. P-H-E-N-Y-L. It's written here. Okay. So name of this will be chlorophenyl methane. Chlorophenyl methane. And the common name is benzyl chloride. Very popular compound, and you need to remember these. Very often we shall require this. So that's how we name the benzylic compound. We have one or two more examples. You see, this is not benzylic, but it follows the same rule. Why is it not benzylic? This is not benzylic because the carbon to which halogen is attached is not attached to the benzene ring. Rather, it is attached to another carbon. Okay, however, the rule is same. Here also the side chain will be the parent group and benzene ring will be the phenyl group. So name of this is 1-bromo 2-phenyl ethane. 1-bromo 2-phenyl ethane. Now here also you have to be careful which one should be 1 and which one should be 2. And 1 and 2 is assigned by considering the alphabetical order. Now let's see the next molecule. In the next molecule, what happened? You see here, it is also isomer of the first one, but here the bromine is attached to carbon 2. Okay. Now the numbering of the carbon chain is, how should we number? The carbon bearing bromine should get position 1. So it will be 1-bromo 1-phenyl ethane. You check the names of these two. They are again position isomers because their set of locants are same. I mean, the set of locants are different. Otherwise, word root and everything is same. Then we move to vinylic compound. How do we name a vinylic compound? You see here, this is an example of vinylic compound. This one. Here the halogen is attached to a carbon which is attached to a double bond directly. Name of this is chloroethene. Because of the alkene group, the name should be ended with "ene", or it is commonly called vinyl chloride. Some of you must have heard the PVC pipes nowadays is very popular, the white colored water pipes and many other equipments. This is called polyvinyl chloride. PVC is full form of polyvinyl chloride. Okay, so this particular compound is polymerized to get the PVC. Next we name a aerylic compound. So here you can see here, this is halogen is directly attached to the benzene ring. So name of this is chlorobenzene. Please understand the difference. Here we are not considering it to be benzene, but here we are considering it to be benzene. The next compound is disubstituted benzene. So here we have bromine and chlorine, two halogens attached here. One is bromine, one is chlorine. Now which carbon should get position 1? Here we have to consider alphabetical order. Since B comes before C, the carbon bearing B should get position 1. So it will be 1-bromo, and we should move anti-clockwise in numbering the carbon chain. So it is 1-bromo 3-chlorobenzene, not 1-chloro 3-bromo benzene. Okay. Now I have given you some more allylic compound, which is example 10.2 in your textbook. Try to check this. I hope you understand. All the explanations are given here and some in-text questions are also discussed. So nomenclature part I am closing here. I am just discussing this structure. You see here the nature of carbon halogen bond. The halogen is more electronegative than carbon, because of which the carbon halogen bond is partially polar, where carbon is the partially positive and halogen bear the partial negative charge, and the carbon is sp3 hybridized. Now all the properties of this haloalkane is because of the polarity of this carbon halogen bond, which we shall be discussing later. So with this we come to the end of this video, and next will be preparation of haloalkanes.